Swayam Prabha. Digital India. Educated India.
Welcome back to the lecture series in Bioelectrochemistry. So, we have finished the first 3 lectures and we have talked about the basics of current and measurement of current, voltage, free energy change, work done, power and the Ohm's law. And we have derived all the basic relations, and those basic relations will come very handy as we will progress. So, as this is a 4 weeks course, so initially I will be going at a very slower pace purposefully. Maybe the first week content may spill over a little bit to the second week, but do not worry about it, because what I personally believe is, if your fundamentals and basics are clear, and once you get it cleared once and for all, then you will be much more well equipped to handle any kind of problems under any kind of situations in the scientific endeavor. So, today what we will be doing, we will be talking about the very basics, what you must have studied in class 11 and 12 about galvanic cells, sometimes called Daniel cells also. So, today's lecture will be about the galvanic cells, where you must all have heard about copper electrode, zinc electrode, cadmium electrode, silver electrode. There are a series of those electrodes are being used, and you have heard about that, from one electrode the current flows from to the other electrode, and likewise and so forth. There are so many, and you have heard how the cells are being represented. You have talked about half cells and everything. So, today we will revisit those basic fundamental concepts in a simpler terms. What does that mean, and in the light of what we have studied in last 3 lectures. So, to start off with, in the last 3 lecture, one thing which I have highlighted every point is, say for example, there is a flow of energy or flow of current or movement of charge from one point to another. So, what are the possibilities? Either it will be a spontaneous flow, where the free energy change will be negative, delta G negative, or it will be energy intensive process, where you have to give energy in order to make that reaction happen, which will be delta G positive. Now, we will take a practical situation where we will talk about 2 metals, where the charge is flowing between them in the presence of a medium, which will be an electrolyte, and in the presence of a barrier, which will allow only the small molecules to pass, not the big molecules. We will come to that. Okay. So, essentially a galvanic cell or a Daniel cell, what we will be discussing today, is a practical situation of what I used to represent in the first 3 lecture, from point A to point B, likewise and so on and so forth. You must have seen it several times. So, today we will talk about a real life situation, where there is a real metal along with its corresponding salt solution, another metal along with its corresponding salt solution, and how do they interact, how based on their work function the energy flows in one direction, and could we reverse the process. So, what we meant by reverse the process? We must have heard about, all of you, we have heard about rechargeable cells. We always say, could we recharge this cell? In other words, say for example, before I get into the technical details, try to understand. Say for example, there is a metal A and a metal B. Now, I am replacing 2 objects. Okay. Now, we know that the current flows from metal A to metal B. What could happen? Say for example, A has, hypothetically think of a situation, A has a higher power to lose an electron. In other words, with respect to B, the metal B, A can lose electron faster. So, if A could lose electron faster with respect to B, that means with respect to A, B can accept electron faster. Okay. So, in other words, the oxidation potential of A is higher. So, A can get oxidized much more faster than B. In other words, B can get reduced faster than A. It's just a vice versa. B can accept electron faster, A can donate electron faster. Okay. Now, say for example, A has donated an electron some way or other, we are not even bothered about it, and B is accepting an electron. So, here is a process where there is a movement of electrons which is happening, and such movement is associated with certain currents. Okay. And why there is a movement, what made us, that how we calculate these kind of things, like why that metal A will be at a higher oxidation potential as compared to B, or if we talk about the reduction scale, why B will be at a higher reduction potential as compared to A, how we compare them. So, we needed a way to compare all these things with respect to something. When we say 1 kilogram or 10 kilogram, so there is some comparison with respect to this, or we say 1 nanometer or 1 meter. So, there is a comparison. So, somewhere out there on earth, we have set like this distance we call as 1 meter or 1 nanometer. Based on that, you can say 10 nanometer or whatever. Similarly, for telling that this has a higher oxidation potential to the other one, we have to have something which is a baseline. With respect to the baseline, we start calculating. So, we will be talking about that baseline value, which is the standard electrode potential or standard electrode. So, say for example, now to start off with, just to give you an idea about how this works, lecture 4. So, today our topic is galvanic cell, which is sometimes also called Daniell cell. Okay, you may come across this word. So, do not get perturbed when you see this word, Daniell cell. And this is not biological cell, this is the electrochemical cell. Okay, electrochemical cell. Now, so when we talk about, there is a flow of current from A to B, right. So, this assuming that delta G is negative delta G, it is a spontaneous process. Now, this will happen when A is sitting at a particular, say, potential P 1 and B is sitting at potential P 2. Now, how we calculated this potential with respect to what? There has to be something with respect to what we calculated these potentials. In other words, we needed a standard. So, that is our P standard. With respect to P standard, we call it P 1, and with respect to P standard, we call it P 2. So, this is that standard we are talking about. Okay. P 1, here we have P 2. Now, calculating this standard, or what we considered as a standard, what will be dealing in the standard electrode potential. Okay. We will come later into that. Now, what we decided, we considered this as metal 1 and this one as metal 2. So, there are two metals, or where we are calculating it. So, let us take a practical example of a cell, electrochemical cell, which is made up of zinc and copper. So, let me make the cell. It is something like this. Think of a big beaker, and which is separated by a porous membrane like this, semi-permeable porous membrane, which selectively allows very small molecules to pass through it. You have a zinc electrode, you can keep on replacing it. Zinc electrode, you have a copper electrode, okay. And here you have an ammeter which is connected to it, and this is solid zinc rod out here, similarly a copper rod, and this is in zinc sulfate solution, ZnSO4, okay, in solution. So, then similarly this is in copper sulfate solution, okay. So, galvanic cell, if we talk about a definition of a galvanic cell, so this is the, I will come back to that figure in a second. I can write here. So, a galvanic cell is essentially a device in which the free energy of a chemical process, free energy of a chemical process is converted into electrical energy, into electrical energy. In other words, here is a situation where, so they are sitting at different energy level, metal A, metal B, and the free energy change. Now, correlate this, the free energy change of a chemical process. So, there is a chemical process from A to B is converted into electrical energy. So, this is what a cell talks about. Usually, not talking about the details of it, usually such a cell consists of 2 electrodes. Okay. Requirements are 2 electrodes, and these 2 electrodes consists of and they are immersed in one or more suitable electrolytes. Okay. Immersed in one and more. We will realize why one and more. At this point, we are talking about 2 different electrolytes. Okay. The one or more suitable electrolytes. When the electrodes are connected externally by a metallic conductor. So, this is a situation when electrode is connected. So, this is the metallic conductor we are talking about, and here we are having the different salt solution, that is zinc sulfate, and on the other side we are having copper sulfate. Okay. When the electrodes are connected externally by the metallic electrode, current flows from one electrode to another. So, okay. So, there is a flow of current across this, which is denoted by red. So, there is a flow of current. So, we will talk about the directionality later. Okay. Current flows from one electrode to the another, and inside the cell chemical changes occur at the surface of the electrode. So, what is happening? There is a second thing which is happening on this surface. There are chemical reactions which are happening. To summarize this, there are 2 important things when the electrodes are connected externally. When the electrodes are connected externally, when the electrodes are connected externally by a metallic conductor, current flows from one electrode to another, from one electrode to another, and inside the cell chemical changes occur at the surface of the electrode. So, now what are the chemical changes which are occurring at the surface of the electrode? This part is important, what we will be dealing with. So, a galvanic cell is also rightly called an electrochemical cell, whereas an electrolytic cell is the one in which electrical energy from the external source is used to carry out a chemical change. So, in other words, if we call this as electrochemical cell, if we are calling this one as electrochemical cell, now if we have to put electrical energy for this reaction to happen, say reverse reaction, we have to give electrical energy, then those kinds of cells are called electrolytic cells. Okay. So, these are the two terms you remember, electrolytic cells. Okay. So, on one hand we are talking about electrochemical cell, the other hand we are talking about electrolytic cell. Okay. Now, in a Daniell cell, a zinc rod is immersed. If you look at it in a Daniell cell, so here you have a zinc rod which is immersed in ZnSO4 solution, and a copper rod. You see a copper rod here which is immersed in the copper sulphate solution. The two solutions are kept separated by a porous barrier. So, here you are having this whole porous barrier. The barrier allows current to pass through it. So, it will allow the current to pass through it. But prevent the mass diffusion, but prevent diffusion of mass, or you can call it mass diffusion. So, it is kind of a does not allow these huge salts to move through it. Zinc and copper are two electrodes. So, here you have the electrode 1, here you have electrode 2, and if you look at electrode 1, you can name this as A to B, okay, whichever way you like to place them. When these are connected externally by a metallic wire, current flows from copper to zinc. Okay. So, essentially in case of current, so here we are giving the directionality, current is flowing from, and why is it so, we will talk about it. Current flows from copper to zinc, okay, through the wire. Okay. Copper is said to be positive and zinc is said to be negative. Copper is considered as positive and zinc is considered as negative. Okay. Why is it so? In this cell, if we talk about in this cell, both electrodes zinc and copper are surrounded by their own solutions. So, for example, copper is surrounded by CuSO4. Okay. So, this is solid and this is in the liquid, it is copper sulphate. Similarly, zinc, which is the solid, whereas zinc sulphate is the liquid, okay, by their own ionic solution. There exists an equilibrium between the atoms in the electrode and the ions in the solution. Now, this part is extremely important to understand. So, please be very careful, and this is one fundamental concept. There exists an equilibrium between the atoms in the electrode, which is the solid part, and the ions in solution. So, here is zinc and Zn plus 2 electrons, which it gives out, whereas copper sitting here Cu plus 2 electrons. Okay. But here you have to realize that zinc has greater tendency to ionize than copper. In other words, zinc has higher tendency to ionize than copper. I am highlighting this part because this is the key to understand this. And so, zinc atoms, now see the reactions at the top. Zinc atom goes into solution, leaving behind two electrons in the metal electrode. Okay. On the other hand, if you look at it, now let us talk about the copper electrode. On the other hand, at the copper electrode, copper ions from the solution are deposited by accepting 2 electrons each from the electrode. So, essentially if we look at it, try to understand what I just now mentioned. So, zinc atom goes into solution. So, you have the zinc electrode. So, here is the cell. So, here on the zinc electrode, what is happening? So, zinc is getting ionized. So, Zn plus. So, here you are left with 2 electrons. Okay. On the zinc, this is what is happening, and it will do it faster as compared to copper. Whereas in the copper, so you have Cu2 plus. Okay. So, this has a tendency to accept electron very faster. So, in order to accept electron, what it will do? It will try to move in out here, and what essentially will happen is it will be needing an electron, and from where it is going to get an electron, and this part is very important. So, okay, coming back. So, we talked about that the zinc has a greater tendency to ionize than copper, and so the zinc atom goes into solution, leaving behind 2 electrons in the metal electrode. So, the metal electrode is now having excess electrons. These are the 2 excess electrons which are there. On the other hand, at the copper electrode, the copper ion from the solution are deposited by accepting 2 electrons from the electrode. So, there is an excess of electrons at the zinc electrode. So, here you have an excess electron at zinc. Okay. and there is a deficiency of electrons at copper. Okay. So, there is an excess electron as a zinc electrode and a dearth of the same at the copper electrode. When the circuit is complete, now you are completing the circuit. Now, once you complete the circuit, the electron flows from the zinc to copper. So, the electrons from here are now traveling here and they come here, and those copper ions which are deposited here becomes Cu2 plus 2 electrons become copper. So, there is a copper deposition which happen. So, this is how the electrical energy or current is produced, which may be used for the purpose of external work. So, this is what the fundamentally what is happening. It is obvious that the zinc electrode, where zinc gives up electron. So, here you are having the oxidation is happening, occurs, and is the anode or negative electrode. So, this is considered as negative electrode because it is having excess of electrons out there, and this is termed as anode. Okay. So, there is an oxidation happening. To remember, here it is, there is an oxidation. Similarly, the copper electrode, where copper ion takes up electrons, copper ions are coming here and copper ions are taking up electrons, there is a reduction process happening. There is a reduction process which is happening, and this is called a cathode or a positive electrode. Okay. So, these are some of the basic fundamental one has to understand, and a galvanic cell could be represented. So, there is a way to represent it by simple representation. So, here you have the zinc plus plus, this is what is happening, this is concentration C1, the double line. So, you have copper plus plus from concentration C2. Okay. So, this is from the solution coming to copper. So, where the vertical lines, so these vertical lines indicate the phase boundaries, the different phase boundaries. So, you are seeing there are two phases. One phase is, so if you look at the electrode, so here is one electrode, say this is the zinc electrode and this is the zinc solution, and here you have the membrane in between, semi permeable membrane, and you have the copper electrode, and this is the copper sulphate solution. Okay. So, the first phase boundary is here and the second phase boundary is here. So, that is why there are different phase boundaries and these vertical lines are indicating. So, this is that phase boundary which is shown by double lines, and this is another phase boundary, and this is the third phase boundary. So, there are three different phase boundaries. This is where chemical reactions are happening. When we are connecting this. So, you realize. So, this is the way you are indicating the reaction, and the real reaction is something like this. The cell reaction or electrochemical cell reaction is like this. So, you have zinc plus copper plus plus, and it is equal to zinc getting oxidized plus copper. So, zinc here went through an oxidation, copper went through a reduction, and this is what the whole redox chemistry is all about. Okay. It is usual custom to write the anode of the cell at the left. So, here we are writing the anode, if you look at it. So, here you are having the anode written on your left, whereas the cathode is written on the right. So, this is a customary thing representing a cell. It is also a common convention that the current is the external circuit is considered to flow from cathode to anode. So, the current, that is why the arrow is like this, from cathode to anode. So, this is a convention. So, current flow is opposite. When we talk about the current flow, we talk about the flow of electrons. So it should be in the direction of electron, right? But the convention is just the reverse. So please do remember, though we know that on the zinc the electrons from here are moving like this, but it is funny, when these conventions were made, they considered it in the reverse way. So if you look at it, it is the usual custom to write the anode of the cell on the left and cathode to the right, representing a cell. This is what we talk about, cathode and the anode, on the left and the right respectively. Okay. And it is also a common convention that the current is the external circuit is considered to flow from cathode to anode, as the direction shows, opposite direction to the flow of, although the electrons are flowing through the wire in the opposite direction from zinc to copper, though electron flow is in this direction. So please remember this fundamental, the flow of current and the chemical changes at the electrode continue as long as the circuit is closed. The chemical action ceases when the circuit is left open and there would be no flow of current. Obviously, if you disconnect the circuit, there won't be any flow of it. Okay. And I will close in here, and the next class we will talk about what are reversible and irreversible cell and how we measure this whole thing. Okay. So, I will close in here, and please go through it carefully, because I tried to be as simple as possible. But then too, if you have a confusion, then on the fora you can send questions. Plus please understand this, because if you understand this basic once and for all, trust me, you can do wonders, okay? And you will do. Thank you.